Hello learners, today we are going to introduce a new unit which is known as binomial expansions. In Form 1 and 2 we discussed algebraic expansions. In this unit we will discuss the higher order of binomial expansions. So the unit is known as binomial expansions. Binomial expansions, and these are going to be our objectives. By the end of this unit, the learner should be able to do the following. By the end of the unit binomial expansions, the learner should be able to, number one, expand. You should be able to expand binomial expressions up to the power of 4. Let me write it this way: up to the power of 4 by multiplication. That would be the first objective. The second objective will be to build up Pascal's triangle. Build up Pascal's triangle up to the 11th row, up to the 11th row, that is up to power 10. Then the third objective, number 3, by the end of this unit, you should be able to use Pascal's triangle. Use Pascal's triangle to determine the coefficients. Up to power 10, up to the power 10. That is the third objective. Then lastly, by the end of this topic, you should be able to apply binomial expansion in numerical cases. This is what we are setting out to achieve by discussing binomial expansions. The first objective, you should be able to expand binomial expressions up to the power of 4 by multiplication. Number 2, build up Pascal's triangle up to the 11th row, that is up to power 10. Number 3, you should be able to use Pascal's triangle to determine the coefficients up to power 10. Then lastly, by the end of this topic, you should be able to apply binomial expansion in numerical cases. In numerical cases. Now, learners, I want you to be ready in our first lesson under binomial expansions. Make sure you have an exercise book and a pen. Then ensure that the environment in which you are studying is conducive. Do not study mathematics when the television is on or when you have external noise around you. Ensure that you are seated in a quiet place that will facilitate learning. In our today's lesson, our first lesson under binomial expansion, we start with the binomial expansion up to power 4 using multiplication. As indicated in objective number 1. Binomial expressions up to the power of 4. By multiplication. So today we'll achieve the first objective. That is binomial expansion using up to power 4 using multiplication. Learners, we will first define the word binomial. What's the meaning of binomial? A binomial, by definition, a binomial is an expression. An algebraic expression, let me say, is an algebraic expression with two terms. E.g., A plus B. Okay, there are two terms here, A and B. You may have another one, 2x minus a half y. This is another example of an algebraic expression. You may have something like P plus Z. P plus Z is another example of an algebraic of a binomial. A binomial is an algebraic expression with two terms. So these are just two terms. This is one term, another term. This is a term, it's another term. So these are expressions. This is an expression with two terms. We have 2x is a term, negative half y is another term. So a binomial is an algebraic expression with two terms. So algebraic expressions, in other words, algebraic expressions which have two terms. Algebraic expressions which have two terms are known as binomials. Algebraic expressions with two terms or which have two terms are known as binomials. A binomial is an algebraic expression with two terms. Remember again, I had said in Form 1 and Form 2 we discussed algebraic expressions and we will in Under the topic binomial expansions, we are going to consider other algebraic expressions which have higher orders or degrees. So I want you to recall, learners, I want you to recall what we learned earlier. Earlier, we learned that a plus b squared, we learned earlier in Form 1 and Form 2 that a plus b squared is equal to a plus b times a plus b. A plus b squared is equal to a plus b times a plus b. If you are to expand, by expanding we mean just removing the brackets. If you are to remove these brackets, then we'll have this expression reduced to a, we multiply a times a, that will give us a squared. A times a is a squared, plus a times b, that will give us ab, a times b, a times b is ab, plus b times a will give us ab, then b times b is equal to b squared, which will give us a squared plus ab is equal to 2ab. ab plus ab will give us 2ab plus b squared. That's what we learned, and you can recall that. Then I come here and take another order related to this one here. You can have a plus b raised to 3. A plus b raised to 3. This is a higher order than this one. Okay, 3 is higher than 2. So a plus b to the power of 3, the degree is higher than that one. So this can be written as a plus b times a plus b times a plus b times a plus b, which can be written as a plus b times a plus b squared. Learners, I want us now to expand. How do we expand? How do we remove the brackets? We know that a plus b, squared is equal to a squared plus 2ab plus b squared. So you'll multiply this by a squared plus 2ab plus b squared times b squared. So that is what we have. A squared plus 2ab plus b squared is the same as a plus b squared. So we can now expand. We'll have this a times all the terms in this bracket, which are a squared plus 2ab plus b squared. Then you'll have plus b, this plus b, we multiply plus b by again all these terms. In the second bracket, we have a squared plus 2ab plus b squared plus b squared. So let's go ahead. We have a times a squared will be equal to a to the power of 3 plus a times 2ab will give us 2a squared 2a squared b. Okay, a times 2ab is equal to 2a squared b plus a times b squared will give us ab squared. We have expanded the first bracket. Let's now expand the second bracket. Plus b times ab is equal to plus, this is positive b times a squared will give us a squared b, then positive b times 2ab is equal to 2ab squared plus b, positive b times b squared will be equal to b to the power of 3, b to the power of 3. Then from there we will group the like terms. So we have a to the power of 3, a cubed, 2a squared b, 2a squared b, 2a squared b is like a squared b. Okay, 2a squared b is like a squared b. It's like 1a squared b. 2a squared b is like 1 squared b. So we have this together. We're going to group these two. All right, these two. So that will give us 2a squared b. We group it with this a squared b. Then we have a b squared. A b squared is like 2ab squared. So we have plus a b squared is like, okay, is like 2ab squared. And then lastly we have b to the power of 3. There is no any other term like this one, so it stands alone. So let's simplify. We have a to the power of 3, 2a squared b plus a squared b is equal to 3. I have plus here, plus. This is plus a squared b plus 2a squared b plus 1 squared b will give us 3a squared b. When you add these two terms, okay, when you're adding the terms, we add the coefficients of these terms. The coefficient of this term is 2. The coefficient of this term is 1. We normally don't write it, we assume. Okay? When it is just 1, you don't have to write 1a squared b. So we have 3a squared b plus ab squared. Again, there is a 1 here, but we normally don't write it. So don't write it customarily. We don't write it. We have ab squared plus 2ab squared will give us 3. We add the coefficients. Coefficient 1 plus 2 is equal to 3. Coefficient 3, ab squared. Then we add this b cubed. So that is the answer to the question. Okay, that's the answer to a plus b to the power of 3. Learners, you can use the same idea to expand binomial expressions, other binomial expressions to the power of 4. This is a plus b to the power of 4, and this is number 2. Number 1, we have done expansion, binomial expansion to the power of 2, Let's do another one. Example, we use the same idea to expand a binomial to the power of 4. This is number 3. That will be a plus b to the power of 4. This is a higher power than 3. So how do we expand this binomial? We know that a plus b to the power of 4 is the same as a plus b times a plus b times a plus b times a plus b times a plus b, which is the same as, this is the same as writing a plus b times a plus b to the power of 3, a plus b times a plus b to the power of 3 is equal to a plus b to the power of 4, because here we have 1. Okay, we have 1 there, so when you add these two, it gives you 3. And we know that a plus b to the power of 3, which we calculated here, a plus b to the power of 3 is the same as a to the power of 3 plus 3a to the power of 2b plus 3a to the power of 3b plus b squared. This we know from what we did here. A plus b to the power of 3 is equal to a cubed plus 3 a squared b plus 3 a b squared, okay, plus b squared. This is plus b plus b cubed, not squared, plus b cubed, okay, plus b cubed. So we can now expand these two. Can expand this by multiplying a by every term in the second bracket, then we multiply b by every term in the second bracket. So this will be equal to, let me push it here, this will be equal to a times a the power of 3 plus 3a squared b, 3a squared b plus 3ab squared, 3ab squared plus b cubed plus b, this b, then we multiply this b with all the terms in the second bracket, that is a cubed plus 3a squared b plus 3ab squared plus b cubed plus b cubed. So we multiply a times a cubed. This will give us a to the power of 4 a times a cubed is equal to a to the power of 4 plus a times 3a squared b will give us 3a to the power of 3 to the power of 3 b to the power of 3 b. Then we add a times 3a to the power of 3a b squared, 3ab squared. A times 3ab squared will give us 3. This is 3a squared. A times a is a squared, then b squared plus a times ab cubed will be equal to ab cubed plus we expand the second bracket, a times a cubed is equal to a cubed b plus 3 a squared times b will be equal to 3a squared b squared. B times b is equal to b squared plus b times 3a b squared will be equal to 3a b cubed plus b times b cubed is equal to b to the power of 4. B to the power of 4. Having done that, we now group the like terms. The first term here is a to the power of 4. There is no any term like this one, so that stands alone. We add 3b cubed b, 3a cubed b, 3a cubed b. 3a cubed b is like a cubed b. These two are like terms, this term and this term, because they have similar powers. This is a to the power of 3, b to the power of 1. This is a to the power of 3, b to the power of 1. So these are like terms. So we put them together. We have 3a cubed b 1 plus a cubed b 1, like terms. Then we move on to the other terms. 3a squared b squared, a squared b squared. We have 3a squared b squared. This term is like this term here because of the powers. The powers are similar. A squared b squared. We have a squared b squared. So we add. We're going to add plus 3a squared b squared, like terms. Then coming to the other term, this term here, a b cubed, we have ab cubed here, so we'll add a b cubed plus this one here. This term is like this term. These terms are like these two, this and this. A b cubed, so we have a b cubed plus 3 ab cubed plus b to the power of 4, b to the power of 4. So we have grouped the like terms, so we can now simplify to a to the power of 4, 3a cubed b1 plus a cubed b1. We first add the coefficients. So here the coefficient is 3, the coefficient here is 1. I said we normally don't write 1. If the coefficient is 1, you don't have to write it, but we know there is a coefficient here. So we add 3 plus 1, giving us 4. Okay, then a cubed b remains. So we have simplified these two. We move on to the other terms. 3a squared b squared plus 3a squared b squared. We first add the coefficients. This is the coefficient of this term. Coefficient of this term, 3 plus 3 will give us 6. Then a squared b squared remains. We add the other, we simplify the other terms. ab cubed plus 3ab cubed. We said if there is no coefficient, then the coefficient is 1. So in this term, the coefficient here is 1. So we are adding 1 plus 3, okay, 1 plus 3 is equal to 4. The coefficient 1 plus coefficient 3 will give us 4. Then the other terms remain, a b cubed plus b to the power of 4, b to the power of 4. So this is the answer. A plus b to the power of 4 is equal to a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the power of 4. That is the answer. So the idea, we've just extended the idea of binomial expansion up to power 4 using multiplication. This is multiplication. A plus b to the power of 3 is equal to a plus b times, okay, a plus b times a plus b, which is the same as a plus b times a plus b squared. So we've used multiplication in expanding the binomials. Binomials. Today we defined a binomial as an algebraic expression with two terms. With two terms. We began with this one here, this term, okay, a plus b times a plus b. These are terms. The second example, we also had the same terms, but higher order, okay, higher power. Then we did question number 3, the same binomial, but with the different order or different power, So that will mark the end of our today's lesson. I want you to practice. I'm going to give you an assignment. Expand a 3x plus 2y to the power of 3. First assignment. B b 2x minus a half y to the power of 4, then c 2p plus q to the power of 3, d 3p minus q to the power of 4. Number 5, that is e, I have x minus a half y to the power of 3. So that will be your today's assignment. Make sure the assignment is done before attending our next lesson. If you have any problem answering any of these 5 questions, expansion, these are binomial expressions, make sure you expand. If you are unable to expand, if you have any challenge, please write to me. I will help you out. But don't attend our next lesson before attempting the assignment. Thank you and bye-bye.